Welcome back to my water slash series. In the previous episode we shaped the mesh and defined the silhouette, and today we are jumping into the blockout. Not the polished effect, but the real process of building it and thinking it through. This is where ideas start to take shape. The early motion, the first forms, and the timing that everything else will depend on. This video will be split into two parts for convenience. And remember, a strong blockout is 80% of the final result. It's like a fast pencil sketch before a detailed painting. A way to explore shape, timing, and energy before any polish. Let's begin. A strong blockout is 80% of the success of any effect. It doesn't take long and you can think of it like a quick pencil sketch before a full detailed painting. It's a fast exploration of the right shape, the right idea and the right timing, long before the colors, textures and polish come in. I'm starting with the texture. For blockout we really only need one or two very simple textures. Since this effect is a slash, the main one I'm using is just a flat white texture as a filler. I trim its edges so later I can slide it smoothly across the mesh. Next, I'm creating a very simple shader for the core. Onto the essential, a texture input, vertex color support so I can control color and alpha directly from the particle system, and a small opacity section with power and multiply. I always finish opacity with a saturate node to keep the values clean. That's all we need at this stage. The blockout should stay simple. I apply the material to the color of the slash. I also keep allow material overrides enabled in Unity, so later I can change the blender mode without recreating the material. It makes iteration much easier. Here I decided that I want the texture to move along the mesh while the slash rotates with the sword. To control this motion from the particle system, I enable custom vertex streams in Unity's shuriken. Then I expose a UV offset parameter in the shader and pass it through the custom stream. Now I have direct control over the texture offset X and Y right inside the particle system. To make the scrolling behave correctly, I switch the texture wrap mode to clump, otherwise the texture would tile or repeat in ways I don't want. With the UV offset exposed, I can now animate the texture position using a regular curve in shuriken. I match the texture motion to the sword motion. Sometimes that means nudging the particle system around, but that's completely normal for blockout. I add a simple color over lifetime curve to fade the core out at the end. I am not removing the texture. It reaches its center point first and then the mesh smoothly fades by alpha. This gives a much more natural fluid behavior. At this point I realize the animation looks too slow, so I go back to Mixamo, find the same animation and re-export it with slightly faster export settings. Inside Unity I rename all animation clips so each one has a clear unique name. It keeps the timeline clean and avoids confusion later. In timeline I replace the old animation clip with the faster one. Now I adjust the core slash to match the new animation speed. Just some repositioning and timing tweaks to keep everything aligned. Here I decide that I want a narrowed core shape. So in the shader I enable tiling and offset on the texture and then simply squeeze it horizontally in the material settings. I add a multiplier to the color section. This gives me quick control over intensity without touching the textures. After a few final tweaks I'm happy with how the core looks for now. So I am moving on to the next part of the effect, the slash outer. Now I am moving on to the second mesh. This will be the outer layer that frames and amplifies the core. I duplicate the material, enable custom vertex streams again and make sure the mesh renders on both sides. Unlike the core, this texture isn't going to slide along the UVs, instead the entire mesh will rotate together with the core. I set up color over lifetime, rotation over lifetime, and adjust the size. I also scale it slightly along the y-axis because I want this outer layer to feel thicker and heavier. Next, I want to add another outer mesh even larger, but this time it will rotate in the opposite direction. This creates a nice contour motion and makes the whole slash feel more dynamic. I simply duplicate the particle system, flip the rotation curve so it spins the opposite way, and rotate the mesh around the y-axis to align its starting position. And then I add a small delay, adjust the color over lifetime curve and reduce its overall opacity. This third mesh will be the most subtle one, almost invisible, but it adds a lot of energy to the final motion. Sometimes timeline doesn't refresh newly added particle system right away. If that happens, the easiest fix is to tweak any parameters on the control track and timeline update instantly, just a small Unity quirk. Now I am moving on to the impact effect, the brightest highlight of the entire slash. I create a new particle system and name it beam. This will be a long stretched glow that follows the slash motion. I only need a single particle with a lifetime of about 0.2 of a second. I keep the shape module and the initial velocity because I want to use a stretch billboard. And that way, the glow automatically aligns along the direction of motion and always looks correct from different camera angles. I duplicate my previous material, rename it, assign it to the particle system, and immediately realize that this particle shouldn't have any UV scrolling. I could have added a switch in the shader, but for this effect I prefer a clean solution, so I decided to create a second shader. I simply duplicate the shader, rename it, and simply delete the entire UV animation part. This shader will stay static, perfect for glows and impact flashes. I assigned the new shader for the material, and now we can finally see our particle. For this highlight I need a soft glow texture. So I quickly jump into Substance Designer and create a paraboloid shape. I export it, assign it to the material, fix the tiling and increase the brightness. This is supposed to be the brightest part of the whole slash. I adjust the particle size and tweak its UV offset inside the renderer module. Then position it roughly where the strike should appear. Spoiler, this position will change several more times. I adjust the lifetime, add a size over lifetime curve that grows very quickly and preview how it feels. I tweak, adjust, look again, tweak, adjust, look again. This is an infinite cycle. And this part is all about the feeling. Now it's time to add particles. My first idea was to make them move in a circular motion, so I tried spawning them around the circle and letting them travel along the shape. But very quickly I realized this approach doesn't match the feeling I want, so instead I decided to use a single particle that follows a control path and then attach a sub-emitter to it that will spawn the actual particle at its position. I make a new material for these particles. It uses the same texture, but the intensity and color settings might be different, so it's easier to keep it separate. The main system contains just one particle. It moves around using a circular shape and an orbital y velocity, which ensures the particle always travels around the same circular path. Depending on what you want, you can use either burst or loop mode inside the shape module. I set its lifetime and use the speed modifier curve so the particle slows down and fades toward the end of its life. Next, I create a new particle system inside the leader. This will be the sub-emitter. I enable the sub-emitter module on the leader and assign the child system there. On the child system, I set the size, count and lifetime of the particles. These particles are also stretched along their velocity, but not as much as the beam earlier. They should feel lighter. And with the simple curve, I can control how many particles spawn at which moment during the leader's lifetime. I disable the renderer module on the leader particle so nothing renders at its position. The leader is just the engine, its only job is to move and generate spawn points for the sub-emitter. Then I preview the motion, adjust the curves, play with timing. I add a size over lifetime curves so the particle appear and disappear small. They never pop in or out. It's a very iterative process. Preview, adjust, repeat. Finally, I add a noise module to break up the movement a little. Without noise, the motion feels too mechanical, and this small variation brings life and energy into the particle trail. Now I'm moving on to the next particle, the fast flash. I duplicate the beam system, rename it, and shorten the lifetime. This needs to be a real quick flash, just a moment of bright energy. I remove the shape module and the all initial velocity because I don't want it to stretch along its motion. I also reset rotation, remove the UV offset from the renderer, and create a new material specifically for the flash. Then I preview it, adjust the color curve so it starts and ends transparent, and tweak the material settings. For the size, I want it to start very small, grow quickly to its maximum, and then slowly shrink back down. Next, I add a system that will spawn particle at the moment of impact. These are the sparks. They are directional cone particles stretch along their velocity. Spoiler: at first I send them in the wrong direction, but later I rotate them back to match the slash. I duplicate the flash system and velocity, change the size, bring back the shape module, and reduce the speed scale. Then I spawn around 10 particles 3 times every 0.03 seconds. This adds a nice burst variation. I experiment with these curves, tweak the UV offset in the renderer, and add drag and dampen so they lose speed very quickly and shrink as they fade. I place the system so it lines up with the beam's straight points and add lots of randomness in size, speed, lifetime, just to make them feel more natural. And of course I preview, adjust and repeat. Now I want to add a second set of sparks, smaller ones, flying in the opposite direction. These are the contour sparks. I duplicate the main spark system, flip their direction, reduce the size, shorten the lifetime, tighten the cone angle, lower the speed, and remove some of their energy. These particles are only supporting the main burst, so I keep their count lower and place them carefully around the impact point. I preview everything again and decide to shorten the initial idle time so the animation feels more dynamic. I also rename the animation tracks inside timeline just to keep everything clean and readable. I go back and adjust the position of each particle system so everything lines up correctly with the slash motion. Finally, I separate the size over lifetime curve so I can control X and Y independently. I want the particle to stay thin but stretch vertically towards the end of their lifetime. That makes them feel sharper and more energetic. At this point, all the main components of the slash are ready and sitting in their places. In the next part, I continue polishing the timing and the overall look of the effect, add more animation, and build a sequence with 2 consecutive strikes. And that's it for the part 1 of the Blockout. We built the core, added the outer meshes, created the highlights, flashes, spark, contour sparks, and shaped the foundation of the slash. It's still rough, still in its early form, but the structure is already here. Next Saturday we'll continue refining the motion, polishing the timing, improving the overall look and adding the second mirror strike to complete the sequence. So if you are enjoying the process so far, see you next Saturday for the part 2. Bye bye!